group assignment. Friday's a wellness day, so we don't have class on the 23rd. So there's no group. So Friday was the last one, last Friday. This week we'll cover chapter 13. So this is week 15. And then next week we'll review. And we have finals week. On Saturday, I gotta click the date here, May 1st. On May 1st, I'll open the take-home part. That's a Saturday. That way you have a whole week, because I cannot collect anything after May 7th, I think it is. And I'll put an outline up and we'll review next week. But it is two parts. There's a take-home part. I'll put it up on Saturday and it's due the following Friday. I cannot take any late work or any work after May 7th, 11:59 p.m. because I need to have everything graded and turned in. The second part of the final is in class. So it will be probably a 1 hour test, but I'll give you the whole 2 hours since half of it will be at home. Yours is Wednesday. Okay, so your final is Wednesday, May 5th, 8 to 10 a.m. Any questions on that? No question. I emailed this out also a week ago. If you looked on Blackboard already, there is this outline for chapter 13. Chapter 13 works with contingency tables and comparing the relationship between two things, for instance, undergraduate and graduate, and female and male. And so you can use a contingency table to see how the two different things relate. This one would say, we looked across here, this is females that are undergraduates and females that are graduates. And then the total number of females at the University of Massachusetts in Boston. I took this one from the book. And then males, undergraduate, graduate, and the total number of males. So when you go across, you're seeing the total number of males and females. When you're going down, you're seeing the total number of undergraduates and graduates. So the total number of students would be 13,433. Any questions on reading the table? So if we wanted the number of males that were graduates, we'd go across for males, down for graduates, 1,037. Any questions so far? Okay. And we'll do probabilities with these. If a student is chosen at random, find each probability. Probability of the student is an undergraduate. Remember, to find probabilities, it's the part, the undergraduate, divided by the total, in this case, the student. So the undergraduates are 10,008, and the total students, 13,433. We divide those. We get the decimal or the percent. Usually we use these in percent form or fraction. On a test, if I don't tell you which way to write it, then it would be up to you. Because of the true positive rates, which we do in the next part of it, those have to be in a percent. I usually use a percent on these. Probability a student is a female. So find the probability a student is a female. And we're going to write it as a percent. When you get the answer, either type it in the chat or say it. But say the percent, one decimal place. $60.1. That's what I got. So we took, for females, we want the number of females divided by number of students. And there were 8,000, we go across, females, 8,068 divided by the total, written as a decimal point 6006. Move it over 2 to make it a percent. And if we go one decimal place, 60.1. Any questions on that one? The next one, student is a female undergraduate. So this would be, she's a female and an undergraduate. So again, rate the percent, 1 decimal place. Getting 42.3%. Female undergraduate would be the 5,680 because we want both female and undergraduate. That's another way this one could have been written, was an and. Female undergraduate, 5,680 divided by the total. Decimal is 0.4228, which is 42.3%. Now these next two, they have a given part. So instead of using the total, you use what's given. It says the probability on undergraduate given it's a female. So since we're given it's a female, we only use that row because we know already it's a female. So then we want the probability of the undergraduate given it's a female. Undergraduate is this, the total females are 8,068. So when you're given a part, then you only use that column or that row, column or row, depending on what was given. So in this case, given a female, we just use this row. Probability it's an undergraduate then would be the 5680 divided by 8,068. When we divide those, you get 70.4. So we only use the row for the females, since that's the part that's given. Go ahead and try the next one. A female given it's an undergraduate. Want to say the answer? Class is so quiet. 56.8. That's what I got. So since it says female given its undergraduate, we only use the undergraduate column. And we wanted the probability it was a female, so that would be the 5680, but it's out of 10,000. So 5680 out of 10,008. Because we know it's an undergraduate, we only use this column. And then the decimal or the percent. Any questions on that? One more I want to do on this one. We did female and undergraduate. When it's an or, that's a different probability because and means it's both, or means it could be female, it could be undergraduate, or it could be both. So you have to be careful when it's an or. When you're finding it when it's an or, it's the probability of the female plus the probability undergraduate. But if we did the probability of the female and the undergraduate, female would be the 8068 and the undergraduate would be the 10,000. But notice that we're adding this one twice because we're adding it here and we're adding it across. So that's why we subtract one of them out. So it's minus the probability female and undergraduate. So you have to subtract out the overlap because we added it twice. When we go across, we add that, and then when we go down, we had it twice. So to find this one, then we'd first find the probability it's a female, which would be 8,068 divided by the 13,433. That was the probability of a female. I don't know what is wrong. Plus the probability of an undergraduate would be here, 10,008 over the total. And then we subtract the overlap because it's in both of them. So 5680 over 13,433. So each probability separate and then subtract the overlap. These are all the same denominator, so you only need to combine across the top and keep the denominator. If we combine the top and then divide by the denominator, moving over 2, we have 92.3%. Any questions on the probabilities? The and, the or, the given. You need to try any more of these. The second part of this sees how good a test is. A person takes a test to see if he has cancer, there's possible outcomes. If you have cancer and the test says you do, that would be a true positive. So positive or negative is what the test says, and then true or false is whether it is right or not. So if the test says you have cancer and you do, that would be a true positive, because the test said positive and it was right. A true negative means the test says you don't, and the true means it's correct. So it means you don't have cancer, the test said so, and you don't have it. That's a true negative. So anytime they're telling you these, that's what they mean. One, the positive or negative is what the test says, and true or false is if it's correct. So like these two, they say the test says you have, well, the first one, the test says you have it, which is positive, but you don't, so it's false. Any questions? So this one says you don't have it, which makes it a negative, but you do, and that's what a false negative means. The test says you don't, but you do actually have it. Any questions on that? So one way you could write it, if the test is positive or negative, and you do have it and you don't. And these are where it would fall then. Always make the test go across. That way you know right where these are, but it also helps you with some true positive and false negative rates if you make your test go across. Okay, so if we had any questions on that, what these mean? This one was an example from your book, a test for diagnosing depression, and it gives these results. Notice what the test says goes across and what the person has goes down. So this would be if the test says yes or no. This one means the test says yes, that you are depressed, and you are. So this would be our true positive. Because the test says you're depressed and you are depressed. And that would be 31. This one would be the test said you are depressed, but you're not. So that would be positive for the test and false because you're not. So this would be a false positive. Because you tested positive, but it was wrong. The next row is testing negative, because the test says you don't have it. So both of these are negative, one's right and one's wrong. So this one says you're not depressed, but you are. So this would be a false negative. The negative was that the test said you are not depressed. The false is because you are. And that's a big amount to miss. This one says you're negative because you're not depressed, and that is true. So this would be your true negative. Any questions on that? So the first column, oh, well, I kind of explained this already, but the first column is people who are depressed. Yeah. Because they're not depressed, and going across is your test. The true positive then were 31 people tested true positive. 50 people false negative. If the person is depressed, what's the probability he is diagnosed correctly? Notice that if the person is depressed, we're already given they are depressed. This is called the probability of the true positive, or a true positive rate. And since we know they are depressed, we're only using this column. And it says, if the person is depressed, what's the probability he's diagnosed correctly? And that would be a true positive rate. So he is depressed. It's 31 out of 81. So our true positive rate is 38%. For those who are depressed, it is accurate 38% of the time. Any questions on that? When you're looking for your rate, you can always use the total below it as long as your test goes across. And that's why I said make sure your test goes across, because then you can always use this total at the bottom, depending on which one you're using. Let's look at the next one. A false negative rate. So false negative is here. If we want the rate, then we're going to go 50 over 81. It will always use the one below it. So what the false negative rate means, the test says you're not depressed given you are depressed. And so it would be 50 out of 81. So the false negative rate is 62%. Of those depressed, this test is wrong 62% of the time. Any questions on that? So looking for the rates, make sure the tests go across, and then you just use the value, the total below it. Go ahead and find the false positive rate. That's the probability that the test says you're depressed given the person is not depressed. So a false positive rate. When you find the percent, go ahead and type it in the chat or say it out loud. A false positive rate. 12%. That's what I got. False positive is here. 34 out of 291 is 12%. So we need to decide if the test is good enough. Well, if we look at where it's wrong, for instance, people who are not depressed and it tells them they are depressed, that was 12%. So if you go in there and you're not depressed, 12% of the time, it will tell you you are. That's not that bad of a percent to be off. But more importantly is when you are depressed and it's wrong. Because those are the people who need it. This extra 12%, okay, they're going to get a little more counseling that maybe they didn't need. But here, this is where people need it and they're not going to get it. And that rate was 62%. So 62% of the people who go in there for help that need it are going to be told they don't need it. That's a problem. And so sometimes on these tests, these people that fall into this category where it says you're not depressed, maybe they need more evaluation just to make sure if you're going to use a test that's off this month. Any questions on that? So when they're off that much, they either need another test or a second test. I think it's the discussion board. When you look at, and I'm sure most of you are familiar with a strep test, when you go and get your strep throat test, and they tickle your throat, they have one they do right there, but then they have one that they send away. Because, kind of like this, the first test gets a lot of them, but it doesn't get all of them. Now, this percentage is a lot smaller with the strep throat test. But still, if you have strep throat without an antibiotic, it causes a lot of problems and it can kill you. And so it's important that these false negatives are found. And that's why they have the quick test so that they can start the antibiotic, but then they send another one out that could take a day to catch any that they missed. COVID has that now too, and that's what your discussion board's going to talk about. Is there any questions on, is the test good enough? Any questions? Are we okay reading it? As long as this goes across like this one did, these will always be in the same spot. So if your test goes across, then these are always in the same spot. And you always use the bottom when you find the rates. Any questions on that? I put out a couple problems. I don't like their questions, but I like their problems. Just to practice setting up a table. So we want to write, and I'll show you what both mean. A frequency table is just the totals. Relative frequency finds the percents. So I'm not really worried about this one. We just find the probabilities after. But this is two-way frequency table, means that you're finding the numerical value. Relative frequency is either the fraction, the decimal, or the percent. A survey asked 615 students whether they had a television in their bedroom. There were 375 boys and 298 said they had a television. 240 girls, 162 said they did not. So we have television and we have boys and girls. So either boys and girls goes down or across. I like to go down. Then we have so going across would be if they had a television. Now you could have went either way, and that's fine. And then on your end is your totals. The survey asked 615 students. Well, that's my total, 615. We'll go here. There were 375 boys surveyed. The boys was 375. And 298 said they did have a television. So of the 375, 298 have a television. Of the 240 girls, so the total for the girls is 240, 162 said they do not have a television. 162. Now I always make sure my totals add up. If we take 375 plus 240, 4, 5, 6, 15, yeah, you get 615. So if we add across the bottom, our totals look good. Now we need to find these two, so then we could add across. Remember, these need to add together to get 375, so if we subtract them, we'll find the number of boys that do not have a TV in their room. I'm going to take 375 minus 298. Getting 77? Yep. Okay, how many girls have a television? What number should go here? So we take 240 minus 162, we get 78. Now add across. Double check. 376 plus 239 is 615. So always make sure you add down. If both ways work, then you probably didn't make a mistake. Any questions on it? So a child is chosen at random. Probability it's a girl. We'll write it as a fraction. So the probability that it's a girl, there's 240 girls out of the 615. 240 divided by 615. So 39%. How about the probability it's a boy and he has a TV in his room? Also find the probability it's a boy or TV in room. And they are not the same answer. Go ahead and find both. So the probability it's a boy and he has a TV. Anyone? For the percent? And means it has to be both. So a boy with a TV would be 298. No, I think, unless I typed something wrong. A boy and a TV would be the two. Oh, I think you added totals. Because it's and, it has to be a boy and a TV, so it's only 298 out of the total. Because it has to be both. We don't want to add these two in there because it's a girl and it doesn't have a TV. So it's only this one. And I got 48.5. So we have to really be careful of the wording. Or means both boys and TV. So it would be the 375 plus the 376. But when we add these this way, and then we add this way, we've added this twice, and so we'd have to subtract it out. Any questions on the and or the or? Let's look at the only other one that causes trouble is the given part. Probability it's a girl given she has a TV. Given that's TV. We want to find the probability it's a girl given they have a TV in the room. Remember the given part, then it breaks it down either to a row or a column, depending on what's given. So given it's a TV, going across is our TVs. So that means we are only using this row. Because we know it's a TV, so then it's something in here, and we want the probability it's a girl, so it's 78 out of the 376. 20 points. Any questions on that? Let's do the opposite. The probability they have a TV in their room, given we know it's a girl. So probability TV. So if it's given it's a girl, that means we're only using the girl column. So we're only using this because we know it's a girl. The probability there's a TV in the room, 78 out of the 240. Any questions on that? So you definitely need to be careful of the wording.